Somewhere out there, around other stars, there are systems that look nothing like ours. Not just different planets, different arrangements, different rules. These are the strangest planetary systems we have ever found. Let's start with the one that breaks your sense of scale. TRAPPIST-1, 7 planets, all of them roughly the size of Earth, and every single one of them orbits closer to its star than Mercury orbits ours. The whole system would fit inside Mercury's orbit, with room left over. And here is what gets me about that. On planets packed in that tightly, the neighbors are not points of light. They are disks, bigger in the sky than our full moon. You would watch the next world along move, night after night, close enough to see weather on it. 8 of these fit in the space where we have one small, hot rock and nothing else. Next, Kepler-16. There is a planet out there that has 2 suns, 2 stars orbiting each other every 41 days, and a planet the size of Saturn going around both of them. So there is no single sunrise there. The 2 suns rise at different times, cross the sky at different speeds, and set separately. Some days they line up. Most days they do not. Everything on the surface casts 2 shadows, and the length and direction of those shadows never quite repeats. This next one is not strange to look at. It is strange to listen to. HD1 10067, 6 planets. And their orbits are locked to each other in a chain. For every 3 laps the inner one does, the next one does 2, exactly 2. And the next pair does the same, and the next all the way out. Which means the whole system is keeping time. 6 planets, beating against each other in a fixed rhythm. And they have been doing it without drifting for 4 billion years. You can convert those orbits into notes. People have. It sounds like music, because it is the same maths. Nothing has knocked it out of step since it formed. Systems like ours are messy. This one is a metronome. Now this next one is just uncomfortable. Kepler-36, 2 planets, and they are almost in the same orbit. One is a dense rock. The other is a puffed-up gas world with a fraction of its density. They should not be next to each other at all. And every 97 days, they pass. At their closest, they are about 5 times the distance from here to the moon. That is nothing. That is nearly touching. From the surface of the rocky one, the gas planet would swell up until it covered a chunk of the sky, drift past, and shrink away again. Every few months. Forever. This one is a mystery, rather than a spectacle. WASP-47. There is a hot Jupiter here, a giant planet whipping around its star in a few days, roasting. Now, we thought we understood how those get there? They form far out, then migrate inward, and on the way in, they wreck everything. Anything small in that region gets scattered, swallowed, or thrown out of the system. Except this one has neighbors. 2 of them, right there beside it, on tight, tidy orbits. They should not have survived. They did, and we do not have a good explanation for it. This next one you can actually watch. HR 8799, 4 giant planets, all of them bigger than Jupiter. Orbiting a young star far enough out that we can see them directly. Not inferred, not a dip in a light curve. Actual points of light next to the star. And we have been photographing them for years. If you stack those images in order, you get something nobody had before this century, a video of another solar system turning. The outer one takes about 500 years to go around, so what you are watching is a few degrees of arc. But it is real motion of real planets around another star. And this next system is not finished yet. PDS-70. This is a star still wrapped in the disk of gas and dust it formed out of. And inside that disk, there is a gap. The gap is not empty. There are 2 planets in there, sweeping it clean as they orbit, still pulling material onto themselves, still growing. We are looking at planet formation happening, not a simulation of it, the actual event, caught partway through. Our system did this 4.5 billion years ago and left no witnesses. That one is doing it now. Beta Pictoris, a young star, tipped so that we see its disk edge on. A thin, bright line of dust cutting across the star, with a planet plowing a lane through it. But the disk is not the strange part. The strange part is what keeps falling in. Comets, a lot of them. dropping toward the star and evaporating so often that we can sit and count them. Every one of those is a piece of a system still settling down, still throwing things at itself, still deciding what it is going to be. And then there is the one that should not have planets at all, PSR B1257+12. This is a pulsar. What is left after a star dies badly. A city-sized ball of neutrons spinning 161 times every second, sweeping the space around it with radiation. And it has 3 planets. These were the first planets ever found outside our solar system. Before we found a single one around a normal star, we found 3 around a corpse. Nobody is sure where they came from. They may have formed out of the wreckage of the star's own death. Second-generation worlds, built from the remains of the thing that killed the first ones. They are being sterilized constantly by the beams sweeping over them. And they will keep going around it for as long as it lasts. And the last one is the closest. Proxima Centauri, 4 light-years away, our nearest neighbor. And it has planets, including one in the temperate zone, the right distance for liquid water. That sounds like the best news in this entire video. It is not, and here is why. Proxima is a red dwarf, and red dwarfs are violent. It throws out flares hundreds of times stronger than anything our sun does, and it does it often. That planet sits 20 times closer to its star than we do. It takes the full force of every one of those. The nearest habitable zone planet to Earth is almost certainly a bare rock, scoured down to nothing, with whatever atmosphere it started with stripped away a long time ago. 4 light-years, the closest door we have, and there is probably nothing behind it. 10 systems, all real, all of them out there right now, arranged like that, whether it makes sense to us or not. And here is the thing that stays with me. Every single one of these was found in the last 30 years. Before that, we had exactly 1 solar system to look at, and we assumed it was the template. It is not the template. It might not even be typical. So, which one of these got to you the most? For me, it is HD110067. 6 planets keeping perfect time for 4 billion years, with nobody there to hear it. Anyway, let me know what you think. And if there is a system or a star you want me to look into next, leave it in the comments. I read every one of them.